Okay, so Elon Musk, right, never seems to be out of the news, does he?
Haha, no, not really.
But this time, oh boy, this time it's about brain chips.
Brain chips, yeah.
We're diving deep today into an article from, let me see, December 2024.
Okay.
And it's from a Spanish website, 3D Juegos, which I think means like 3D games.
That sounds about right.
Something like that. Anyway, they cover gaming and tech, and they've got this piece about Elon Musk and some pretty wild predictions he's made about, you guessed it, Neuralink.
His company.
Yeah, his brain-computer interface company.
Right, and the predictions are pretty out there, just the scale of what he's talking about. Like, by 2030, he thinks 1 million people will have these Neuralink chips.
1 million.
1 million, but it gets even crazier. By 2045, he thinks it'll be hundreds of millions.
Hundreds of millions. Hold on. So, like, everyone's going to have a brain chip.
Well, not everyone, but that's a huge number of people. And that's not even the wildest part. He's claiming these chips could make our brains work like way faster, talking 3, 6, maybe even more orders of magnitude faster.
Okay, hold on. Orders of magnitude. I'm not a scientist. Break that down for me.
Sure. So 1 order of magnitude means something is 10 times bigger. 2 is 100 times. So 3 orders of magnitude would be 1,000 times faster. Just massive. Even 1 order of magnitude would be huge. Like our brains would be processing information so much quicker.
Whoa, that's a lot to process.
Yeah.
Even without a brain chip.
Yeah.
But, okay, let's back up a bit. What exactly are these Neuralink chips, and how do they actually work?
Right, good question. So basically, they're a type of brain-computer interface, or BCI. It's all about creating a direct connection, a pathway between your brain and, say, a computer.
So I could, like, think something and it would happen on the computer.
Exactly. And Neuralink's way of doing this is they implant these tiny electrodes in your brain.
In your brain.
Yeah. And these electrodes can pick up on the electrical signals from your neurons, which is how your brain communicates. Then the chip processes these signals and turns them into commands that can control things outside your body, like a computer or a prosthetic limb.
So it's like translating brain language into computer language.
You got it. And get this, it's not just theoretical. Neuralink has already had some pretty impressive successes. Just this year, they've implanted these chips into patients, and those patients can now control computers and devices just by thinking.
No way. So like someone who's paralyzed could, I don't know, use a computer or even walk again.
That's the idea. For people with paralysis, this could be absolutely life-changing. Imagine controlling a wheelchair or prosthetic limb just with your thoughts. And it goes beyond that, too. BCIs could potentially be used to treat all sorts of neurological conditions like Parkinson's, epilepsy, you name it.
That's incredible. I mean, just the potential for good is huge. But the article also mentioned some of Musk's more, let's say, controversial claims. Like he suggested that Neuralink could cure autism and schizophrenia.
Yeah, and that's where things get a bit tricky. While it's definitely important to explore all possible uses for this tech, calling complex neurological differences like autism and schizophrenia diseases that need to be cured well, it's not really accurate.
Right. It's not like they're just illnesses that you can fix with a chip.
Exactly. Autism and schizophrenia are part of the spectrum of human neurodiversity. They present challenges, for sure, but they also come with unique strengths and perspectives. To say they need to be cured kind of ignores all that.
It's like you're trying to erase what makes someone who they are. And speaking of erasing things, the article mentions something even more sci-fi. Uploading and downloading memories. Like, are we talking straight up Matrix territory here?
Well, downloading kung fu skills might be a little ways off, but the idea itself isn't totally crazy. I mean, we're talking super theoretical here, but imagine instantly learning new things by downloading info right into your brain, or preserving your memories, like forever, passing them on to future generations.
That's a lot to wrap your head around.
Yeah.
I mean, it's kind of cool, but also, wouldn't that change what it means to be human? Like, if you could swap memories, would you even be the same person?
Right. Big questions. What happens to individuality if your memories aren't entirely your own? We're talking at the very essence of who we are. And all this is assuming it even works. Which brings us to another point.
Yeah, Musk isn't exactly known for being, shall we say, realistic with his timelines. I mean, remember self-driving Teslas, colonizing Mars. Those were supposed to be happening by now.
Aha, good point.
Yeah.
It's exciting to think about the possibilities, absolutely, but a healthy dose of skepticism is never a bad thing. We got to be realistic about timelines and really think about what could go wrong, the unintended consequences.
So what's the takeaway for our listeners? It sounds like this BCI technology has the potential to, like, revolutionize healthcare and change how we interact with the world. But there are also some serious ethical questions and potential downsides we need to think about.
Totally. This technology is moving fast, and it's going to have a huge impact on all our lives. We need to talk about this stuff, and we need to talk about it now. The benefits, the risks, everything. And we got to make sure ethics are front and center.
Right. Because this tech is going to change the world, whether we're ready or not. And as we've talked about today, it raises some pretty big questions about what it means to be human in this age of crazy fast technological advancements. So, what do you think, listener? Are you ready for this brave new world? And if so, what will your place in it be?
Think about it.
That's all from us today on this deep dive.
See you next time.
Bye.
Bye.